In today's video, we'll discuss coning of wheel. This coning of wheel is a topic from the second module. So, if you are going for the syllabus, you can understand this module 1 and module 2 is actually connected. What we learned in the last class was permanent way, then its components, that is mainly sleepers, ballast, then formation, sleepers, etc. So all these things I have told you or we have discussed in the last class. And one more thing we have to learn in detail is the rail fastenings. So I'll tell you about that in the coming classes. So in today's class, we'll go for coning of wheel. Okay. So what do you mean by coning of wheel? In this picture, what you can see is this portion, okay, this straight thing, what you can see is the axle of the wheel. It is named as axle of the wheel. Then you can also notice that this diameter or this circumference is lesser compared to this circumference. Now, this portion you can see and this portion you can see. This portion is having a circumference more than this portion. Okay. Maybe this is not clear to you in this figure. I'll show you another figure. See, in this figure, it will be more clear. This is the sleeper. Okay. On the sleeper, rails are kept. Okay. On the top of rail, you will have wheels of the train. Okay. This portion is the axle. Okay. Now, what you can see is, this is the thread of the wheel. What do you mean by thread? Thread means it is the portion which is coming in touch with the rail. Okay. So, this is the thread portion. What you can notice here is, this height or this diameter or this circumference is comparatively less compared to this portion. Same like here also, this is having more circumference compared to this portion. So, evidently you can understand that this is sloped. Okay, it is made in the form of a, if you are extending this, this will be made in the form of a cone. Okay, now we have to understand why do we provide this coning. Okay, so this is actually shown in the case of a wheel which is centrally placed on rail, and this happens in a straight track. Okay, now when the train has to encounter a curve, okay, if the train has to go through a curve, and just imagine that instead of keeping this wheel not in sloped position, if it is kept flat, what happens? If it is kept flat, what actually happens is, there will be the tendency of the train to move out of the track when it encounters a curve, or because of the centrifugal force. If it is made flat, if the wheel of the track is made flat, the tendency of the train will be to move outside of the track, which will cause problems. It may cause derailment also. So, in order to avoid this, we are providing coning of wheel. The thread of the wheel of a railway vehicle is not made flat. Flat means it is not exactly made in rectangular shape, but it is being sloped, and that slope is 1 in 20. 1 in 20 means 1 vertical and 20 horizontal. This alignment or this sloping is being given, and that is like a cone, in order to enable the vehicle to move smoothly on curves as well as on a straight track. Okay. So this is another close-up picture. You can see here, this is the railway track. This is the wheel of the vehicle. This is the portion which is having a lesser diameter or circumference, and this portion will be having, this flange portion will be having a higher diameter or higher circumference. Now you can understand that there is a gap in between. Okay, when it has to go through a straight track, the gap what you can see here between this rail and this portion will be same as that you can see on the right side of the wheel. If it has to encounter a curve, then what happens? The outer wheel portion, okay, the outer wheel portion will come closer to the rail, and then the moving happens. Okay, so I'll just explain it while showing the figure. So this is again showing the rail wheel thread. This I have already explained you what it is. Now coming to the curves. Due to the action of centrifugal force, what happens on a curve? The vehicle tend to move out. You can see this train coming and it has to encounter a curve. Now if it is not being sloped, okay, if the wheel is not being sloped, it has a tendency to move out. Since it is sloped, then only or because of that only, the vehicle is able to turn very smoothly. Okay. The wheels of the railway vehicle are connected by an axle which is turned fixed on a rigid frame as shown below. This is the axle. It is a rigid frame which is being provided, and this is the rail. This is again the rail. What you can see here is the coning. Okay. This portion is having a larger circumference. This portion is having a lesser circumference. Same like on the left side, you can see on the right side also. Now, what is the proper arrangement in the rail? Here you can see that it is the sleeper. In the previous figure I have shown you the sleeper is in a straight line. But actually, or in actual scenario, it is not in a straight line. Or if you are going to railway tracks, you can notice that sleeper is having a depth uniformly in the middle portion only. Coming to the sides, what happened? It is having a slope. And the slope is same as that of the wheel cone. Okay, the wheel cone has a slope of 1 in 20. In the same manner, here also in the sleeper, a coning is being given and that slope is 1 in 20. Okay, now this is the, just imagine, this is the inner rail and the outer rail, which means that the train has to move in the left direction. If the train has to move in the left direction, what happens? The train will be moving like this. I'll show you like this. In this direction it has to move. Okay, so this becomes the inner rail and this becomes the outer rail. Now, what you can notice here is, since we are providing the flange thickness more, when it is going to a left side, which is here, this is the outer wheel. There is no gap in between the rail as well as the flange portion. Whereas here what you can see is, there is a huge gap. Not actually huge gap, there will be a difference in this portion. Understood? So, here some distance you can notice and here there is no space in between, because in order to keep the railway track railway wheel in position, we are giving the slope. Since we are providing this slope, because of the slope only, it is not going away from the track. Okay, this is what is actually happening in the real scenario. Now, what are the advantages of coning of wheel? It controls the differential movement of front and rear axles, thus acting as a balancing factor on curves. Rear axle has a tendency to move towards the inner rail. Okay, so if it is made flat, what actually might have happened was, it will go in what manner? It will go in such a manner that it will be going away the track if it has to move through a curve. Clear? Next, smooth riding, as it helps vehicle to negotiate the curve smoothly. It reduces the wear and tear of wheel flanges. Okay, so since we are providing this coning, what happens is, you can understand, I have told you that there is a small gap in between. The gap in straight rail, what happens is, that gap will be equal for the left wheel as well as for the right wheel. Since we are having that gap, that wear and tear of the wheel does not happen. Now, when it is going through a curve, it can have a left curve or it can have a right curve. If it is going through a left curve or if it is going through a right curve, what happens is, if the centrifugal force makes the train to move out, the arrangement is made in such a manner that it does not goes out. And because of this arrangement, the outer rail, not rail, what I am saying is about the wheel. The outer wheel comes very close to the outer rail. Okay, and what you can see in the inner rail is, there is a sufficient gap in between the inner rail as well as the wheel. Okay, the outer rail distance on the curve. So just imagine that this is the portion what I am starting, or this is the portion. Now a train has to reach up to this portion. Okay, now the distance which this is the inner wheel, this will be the inner curve, this will be the inner rail. This will be the outer wheel, here it will be having the outer wheel, here it will be having the outer rail. So if from here to here, if the train has to cover a distance, then what you can notice here is the inner wheel or the inner distance will be less compared to the outer distance. That means the outer wheel has to cover a larger distance compared to the inner wheel. Okay, so in order to make you understand, just saying the example, if this is the, from here, if you are considering the distance to be covered up to this portion, just think from here to here, the inner wheel has to travel. From here to here, the outer wheel has to travel. From this itself, you can understand this distance to be covered will be more. Okay. Now, if this arrangement is made in such a manner, it has to cover more distance, then the rail, what happens to the wheel is, it can go in a smooth manner. Okay. There will be no problem in the movement of train. It can move smoothly.